So we're going to talk about angular and translational kinematics. This we've done already, and so if we have position, for position we use x or y or z or something like that. For angular position we use angle, right? For velocity we use v, and here we use omega. Angular velocity is omega, translational velocity is v. For acceleration, here we use a, here we use alpha, right? And so if you remember these equations, right, we had some definitions. Velocity was equal to change in position over change in time, and technically that was the average velocity. Similarly, the average angular velocity is change in angle over change in time, right? This was change in velocity over change in time. This one is change in angular velocity over the change in time. And finally we said, V average is equal to V plus V naught divided by 2. Here omega average is equal to omega plus omega naught divided by 2. Notice these are very much the same, right? I measure my position. My average velocity is the change in position over change in time. My acceleration is change in velocity over change in time. My average velocity is initial plus final over 2. And here we assume constant acceleration. In our problems. And so when we started with these equations, right, over here we rearranged these and we derived the following. We said x is equal to x naught plus v average times time. We had v is equal to v naught plus acceleration times time. We had this equation, v average is equal to v initial plus v final over 2. We had x, then we rearranged these. This is just a rearrangement of this. This is just a rearrangement of that, and this is just the same as that. And then we use these to get x equals x naught plus v naught t plus 1/2 a t squared, and then v squared is equal to v naught squared plus 2a x minus x naught, right? Well, since these equations are the same, we can write down the exact same equations here. I can say theta is equal to theta naught plus omega average times time. That's just rearranging this one. And then I can say omega is equal to omega naught plus alpha times time, right? Where here I've replaced delta t with t, just like we did for kinematics. Omega average is equal to omega plus omega naught divided by 2. Theta is equal to theta naught plus omega naught times time plus 1/2 alpha t squared. Omega squared is equal to omega naught squared plus 2a plus 2 alpha theta minus theta naught. Just by analogy, if these questions are the same, that's how I define those things. Then I can just change my symbols to get those three equations, and then from these I can derive these two. And so it's the power of mathematics to show that when I define the things for translational motion, and I define analogous ones for angular motion, all the equations are going to come out the same. A mathematician might look at this and say, why are you wasting all this time? Just call this variable position, and if you're talking about translation, it's translational position. If you're talking about angle, it's angular position. We in physics say, you know what, we'd like to have different symbols for those, and so we write two sets of equations that look almost exactly the same. They just have different names. The mathematics of them is the same. And so you should be able to, all of the problems we did with translational motion are going to look almost exactly the same and solve almost exactly the same, except instead of talking about meters, we'll be talking about radians or degrees or something. Instead of velocity, we'll be talking about angular velocity. Instead of acceleration, we'll be talking about angular acceleration. But the time and stuff like that, all the math will be the same. So this is an example. A deep sea fisherman hooks a large fish that unwinds line from his reel, which has a radius of 4.5 centimeters and is initially at rest. If the angular acceleration is 110 radians per second squared for 2 seconds, what is the final velocity, right? And so this is the radius. Say it's spinning this way, right, as the fish is taking line off, right? This is the angular velocity omega, or the angular acceleration. It's omega is steadily increasing, right? And so we get omega is equal to omega naught plus alpha times time. Omega naught is 0 because it started from rest. That says omega naught equals 0, right? And so that's just alpha times time, which is 110 radians per second squared times 2 seconds, which is 220 radians per second. So that's omega. Right, that's the angular velocity. So the question is, what is the speed of the line, right? The fish is pulling the line out, right? And the speed of the line is the same thing as the tangential speed of the reel. And so we can just say V is equal to omega times R, which is 220 radians per second, times 0.045 meters, which is 9.9 meters per second, just under 10 meters per second. So during this time, how many times around does the reel go? How many revolutions does the reel make, right? Well, this is asking for theta. And so we can say theta is equal to theta naught plus omega average times time, right? Well, if we pick our initial position as 0, just like x naught we usually do, then that's just omega average times time, right? Well, omega average is just omega plus omega naught over 2. And if you remember, that's just, this is 220, right? That was our final velocity. Our initial velocity was 0. Divided by 2 is 110 radians per second, right? And so theta is equal to 110 radians per second. That's our average velocity times 2 seconds, which is 220 radians, but it didn't ask us for radians, it asked us for revolutions, and so that's times 1 revolution over 2 pi radians, because that's a circle, right? And what I get for that is about 35 revolutions. I think there's one more question. Question D, I'll just come back up to here to where A is. D. How many meters of line come off the reel, right? Well, we can do it a bunch of different ways. The arc length is the radius times the angle, right? This is what we calculated, the angle, and so it's equal to r times theta. This is the length. This is how much distance around this thing this angle corresponds to. We'll do it in radians because that's the one we want. Is 0.045 meters times what was the total distance? The total distance was 220 radians, which is 9.9 meters of line. I don't know if I had all of that on there, but okay. So continuing the fisherman problem, the fisherman puts a brake on the reel and brings it to a stop with an angular acceleration of negative 300 radians per second squared. In other words, it's slowing it down rather than speeding it up. Its change in velocity is in the opposite direction. And so we can just look at our list of equations and say, well, this is omega equals omega naught plus alpha times time. In this case, omega naught is the initial velocity. That's how fast it was going. This is 220 radians per second. And omega is equal to 0 because we bring it to a stop, right? And so this gives us omega naught plus alpha times time equals 0, or time is equal to minus omega naught over alpha, which is minus 220 radians per second. Let me try that again. Radians per second over 300 radians per second squared. And what I get for that is about 0.73 seconds. Then we can ask the question again, how far does it rotate in this time? Theta is equal to theta naught plus omega average times time. Again, omega average is just omega plus omega naught over 2, which is 110 radians per second. That's our omega average. We know what the time is, right? And so theta is equal to the distance it turns. Again, theta naught, we'll just call it 0 when it's reached its maximum speed. And this is 110 radians per second times 0.73 seconds. Lost my calculator. That's 80.3 radians. If I want to, I can turn that into revolutions, right? By 1 revolution over 2 pi radians. .8 revolutions. We can also ask the question, just like we did before, how much more line went out while this thing was coming to a stop, right? And we just said the arc length is equal to the radius times the change in angle, right? Or the angle. In this case, I'll just call it theta because the delta theta is the same as theta. Theta minus theta naught is delta theta, but theta naught is 0. And so this is just 80.3 radians times 0.045 meters for the radius. .6 meters.